If ABC is an equilateral triangle inscribed in a circle and P be any point on the minor arc BC which does not coincide with B or C, prove that PA is angular bisector of PBC. So we have an equilateral triangle, that is one thing, and it's inscribed in a circle. That is what? It is in a circle, something like this. It is almost an equilateral triangle, I guess. It looks so. Okay, let me call this as ABC. Now, what is the question telling? We have a triangle which is inscribed in a circle. Good. And we have a point P, any point on arc BC. So this is BC. So we have some point, say P over here, which is any point within this. It should be a random point. Don't take in the middle. Again, you won't get to see that variation and you won't get to get confused, and so you won't be able to learn anything over there. So we have to prove that PA. Okay, let's join this to understand what is happening. This particular line is an angular bisector of PBC. So PBC is this. First thing first, before we proceed with anything, since we are talking about angular bisector, we need to discuss about the angles of the equilateral triangle. What is that? Each of this angle is equal to, yes, each of them will be equal to 60 degrees. So 60, 60 and 60. So it's an important fact. We'll make that observation. And now I'm able to see the answer. I have it in front of me. Can you guys figure it out? And the clue is on your screen. The next clue is that it is this what we have to use. And the next clue is that, come back to the diagram and have a look. Okay, so think about it. And the last clue is this. Are you getting it? The very last clue. Do you guys get that? Yes, no? Yes, right? Since this is 60, this has to be 60. Okay. So how is that? I'll proceed after this. Think about it. I'm sure most of you would have got the answer. So others, you can take your time. You can pause, or by the time I write all of this, you guys can think about it. So we have any kind of construction? None, I guess. No. So to prove PA is an angular bisector. Of angle PBC. Proof. So first thing first, as triangle ABC is an equilateral triangle. Yes, even though we know that it is 60, we'll just write it off. Is an equilateral triangle. Angle BAC will be equal to angle CAB will be equal to angle ABC. And all of this is equal to 60 degree. Okay. Next thing, angle BCA, this particular angle is equal to angle PBA, and both of them will be equal to 60 degree. But why? Reason is quite simple. AB is or we can tell angle subtended in the same segment are equal, right? Angle subtended in the same segment of a circle are equal. Subtended in the same segment of a circle are equal. So these two are 60 and 60. Next, what do we have? we have next part is this. We have this as our base, right? And this angle will be equal to this angle, right? Is it not? So this will be 60 degree. So we have angle ABC is equal to angle APC. Both of them are equal to 60 degree. So same set of reasoning, you don't have to write. So from 1 and 2, what can we tell? Yes, that from 1 and 2, we can tell the following. Or let me write it in the fresh sheet itself. So from 1 and 2, we can tell that angle, what is it? BPA is equal to APC. BPA is equal to angle APC. Both of them are equal to 60 degree. So what does this imply? That PA bisects angle BPC, right? That's it. That is your answer.